Hello, everyone. Quack, quack, quack. My name is Ryan Boyd, and I am a co-founder at a company called MotherDuck, which is building a cloud version of DuckDB. But today here, largely I'm talking about DuckDB as an open source project. So the title was If a Duck Quacks in the Forest and Everyone Hears It, Should You Care? And I would argue that yes, you should care because everyone's hearing it. As to whether DuckDB is useful or not for your use cases, I'll leave that up to you. But I think it's still valuable for you to learn the content in this presentation either way so that you can make good choices. The hashtags up here, DuckPost, DuckTalk, are actually in reference to kind of memes been going around on Twitter for those of you who have seen them, where it's like, you know, everyone is doing their duck posts. They're basically posting about how amazing DuckDB is, and generally the internet has gotten sick of it over the last year. But DuckDB is widely praised for good reasons, and I'm going to be talking about them here today. So this is an explanation of the industry context in which DuckDB came to life. It is a discussion on the open source DuckDB and its features and values. It is a spotlight on the internals of DuckDB and why it was architected the way it was, a demonstration of DuckDB's capabilities, and last but not least, a little bit of a preview of MotherDuck and its architecture. So if you were around back in the 1940s to 1970s and writing code, by the looks of the audience, probably not many of you, but if you were around back then, you had this centralized compute infrastructure. So centralized compute, you had mainframes that were optimized for the operator. You would get your punch card decks and your data cards, and you would stand in line and feed them to the operator and get your results. These really introduced computing to the world. And because of that, very valuable for our industry. You know, they provided this powerful centralized compute and shared access. You could access these if you were at a wealthy enough academic institution or a big enough company. And so, you know, because of that, you really got access to very powerful compute, but they were bulky. They were not very personalized, and this became you know, something that the industry sought to improve. So the PCs came along, and they really popularized computing because they were dedicated and personalized, because you could run your code without worrying about impacting the work of others, and you could have all your settings and all how you like them and such. I'd argue that today's modern day data warehouse is really yesterday's mainframe. It is a centralized environment that is configured to work best for the operators and the average user, but not the individual user. It is not personalized at all. It is shared compute. Companies often under-resource their cloud data warehouses because it's expensive. And they under-resource them, meaning that when you go to run your jobs, it may be running a lot slower than it needs to be. Yet, as I'm presenting here, I'm presenting on a laptop that has 32 gigabytes of RAM, 10 cores, and sits idle 85% of the time. You know, basically, it's relegated to handling a few Chrome tabs. Maybe it's only 50% idle if I'm running Google Meet, but you know, otherwise, this machine is sitting here idle, yet I have these under-provisioned cloud resources. So how do we use these two things together? How do we use my laptop in concert with the cloud resources? And I'll make one of my few puns. That would be just ducky, wouldn't it? And I think it would be ducky, and it's enabled by DuckDB. So the majority of the beginning of this talk is going to talk about DuckDB running on your own computer somewhere, your laptop, your desktop workstation, what have you. And then we'll talk a little bit about the cloud side of things. But DuckDB has gained its popularity largely because it offers the flexibility that people want. DuckDB is an in-process SQL OLAP database management system. Every time I read that, I immediately think this had to have been written by an academic, and it was. DuckDB was created by Mark and Hannes here. Mark on the right, Mark was the PhD student working on his dissertation. Hannes was the professor. Hannes is actually giving a keynote here on Thursday, so look forward to that in the morning keynotes. And it was created at CWI, Dutch National Computer Science Research Institute. Today, it is maintained by the DuckDB community and foundation, and you'll find a lot of the PRs are actually committed by DuckDB Labs folks, which is the consulting company that Mark and Hannes now have created. So it was written by academics. Let's talk about what that means. Let's break it down. So in process, it runs inside your Python, your R, your C++, your shell environment. It has no external dependencies. The binary can be as small as about 2 megabytes. So it's a very lightweight system to add SQL capabilities to your application. So the center part of this graphic here is just, it's processing all of the SQL queries through the pipeline and giving you the results. And what are people using this for? Well, it's for analytics, OLAP, online analytical processing, as opposed to transactional. It is about giving you full SQL support to do large-scale aggregate queries. And it includes support for things like window functions. For those of you who haven't seen it thus far, they try to actually give you most of the SQL support of Postgres and maintain the syntax of Postgres while adding some niceties on top of that. But really good for high-performance aggregations. And a lot of people will call this the SQLite for analytics. Now, why is it the SQLite for analytics? SQLite is also an embedded system. SQLite is probably more widely deployed than any other piece of software. If you look at your phone, there's probably a dozen different copies of SQLite on your phone, in your web browser, on web applications, on server-side applications, desktop applications. SQLite really powers a lot more than we know. But it is a transactional database. It is meant to do transactions, and it is not meant to do high-performance analytics, although they are evolving SQLite as well. But so this is a really good way to explain DuckDB. For those of you familiar with SQLite, it's SQLite for analytics. Now, why did they create DuckDB? They created DuckDB because of conversations that they had with the data community at the universities that they worked at and studied at. And the data community largely used R. They were processing research data, and they were doing this in their code, in their custom data frame stuff. They were not using a quote-unquote real database, as Hannes calls it. And Hannes himself is very much a fan of real databases. He works in the database architectures group at CWI. And what does a real database mean? Well, it means support for SQL. It means ability to run these things high performance, to do ACID transactions. It doesn't mean writing a bunch of data frame logic. And so he was kind of sad for these folks that were stuck in R without a real database, and he asked them, why are you not using a real database? And they said, well, real databases require a lot of setup, configuration, maintenance. It requires low performance socket connections between our code and the database, and we just don't want to have to deal with all that crap. We'd rather take these CSVs and parse these CSVs inside our R code and not have to deal with this extra piece of software. It's a lot more portable, and it's just a lot easier for us with our skill set. So they said, we're going to fix that, and we're going to create this thing called DuckDB. And I would argue that the reason everyone loves DuckDB is because of these 4 points. It has a high-performance architecture. We're going to go into that architecture. It provides simplified data access and a really good developer experience. It has an open source community that has been rapidly growing and supporting each other. And it quickly grows in terms of its capabilities and performance. And by that I mean is like you'll see academic white papers come out, and then 3 weeks later, DuckDB will have implemented what was in those academic white papers in DuckDB. And it's pretty fascinating to see. So the architecture. Databases typically have these 3 different types of actual storage and processing of the data. So you either process the data as tuples or in columnar or in a vector-based columnar way. And for those of you who know me from my past, I did work for like 5 years at Neo4j, so there are other types of databases here as well, like graphs, but we're going to be talking about these three. Row-based databases are great for transactional workloads. When you sign up for an application, you basically need to create a row in that database saying your first name, your last name, your email address, maybe an ID, maybe a salted hashed password. And when you log in again, you need to retrieve that. You don't need to do lots of analytics, and row-based databases are great for that. Columnar databases, however, are really great for doing large-scale aggregations. They can compress like data, because what's in a column is often very similar types of data. And when you work with a columnar database and doing these large-scale aggregations, you are typically only accessing a single column or two. So it really optimizes the amount of data that you need to read and have I/O latency on. But then there's vector-based columnized engines, or vectorized columnar engines, as it should have said. And these are really good for analytic workloads as well, but they chunk those columns down into vectors, and those vectors can be processed much more efficiently by modern CPUs. So modern CPUs that have support for SIMD, or simultaneous instruction multiple data, can take multiple of these vectors at the same time and process them. Modern CPUs that have really good caches, you can optimize the size of these vectors for the caches. So a typical CPU architecture, you have L1, L2, L3 cache in decreasing order of performance, and then main memory. These are numbers from an M1 Max laptop, my laptop here. These are actually fairly large numbers. They're fairly large sizes of L1 cache, L2 cache, L3 cache. But when you have these vectors, you can basically optimize the size of the vectors to fit within these caches and optimize the size of the intermediates as you're doing your SQL processing to fit in these caches and thus have a lot higher performance. Now, I talked about the memory consumption of DuckDB and the way that the memory usage is optimized with DuckDB. And a lot of people, I've actually talked with people that have spent weeks using DuckDB and not realized that DuckDB has a native storage format. They thought DuckDB was an in-memory database. And it felt like deja vu to back when I worked on Neo4j, to be honest. People think, hey, this has to be in memory because it's so fast. But DuckDB, when you run the command line client, or if you load the library in Python or something like that, yes, it uses memory by default, but they've actually implemented their own storage format, a native storage format. It does support larger than memory queries. You can spill over to disk for your intermediates and your results of your queries. And their native storage format is columnar. It is partitioned, very much like Parquet in that sense. But it supports efficient ACID-compliant queries, which is very much like an Iceberg or a Delta. The one big difference between DuckDB's format and Parquet or Iceberg or Delta is that it stores an entire database, not just an individual table. And they did this because of that original use case, because of working with those data folk who were analyzing their data in R. They really wanted it to be portable. They wanted it to be really easy to say, hey, even just email this file over to someone and give them access to the data. So they made it so there's a single file that represents the entire database in DuckDB. Now, that doesn't mean that there's not optimizations that occur beyond the table level or in smaller chunks than the table level. There are, in particular around the compression algorithms. I'm going to go through two examples, pretty simple examples here, but this is a dictionary compression. We're literally just storing a binary number representing the place in the dictionary when you have often repeated strings. And then there is another algorithm here called FSST, which basically means that we are dealing with substrings in our dictionary instead of the complete string. And so we're able to reference, in the first line here, www.google.com, we basically able to store 3 ints to represent that whole string instead of however many bytes that would be otherwise. So these are just 2 of the algorithms, the compression algorithms that DuckDB supports. I want to give you, I'm going to go through a little more of this later, but I want to give you a sense of the amount of effort that is put into optimizing DuckDB here. You can see here from DuckDB 0.2.8 down to 0.5, we actually have dramatically changed the amount of storage that it takes to store data. And this is the New York City taxi data set going from 15 gigs down to 4.8 gigs. And this is as of November last year, I think. So this is a while ago. And they continue to improve that. And improving the storage of data doesn't just help you save on disk space, but it also improves the performance as that data is piped through the application and through the different operators. So you can actually see in DuckDB your storage information on your own tables, and you'll get a result that looks something like this. What it shows here is that for an individual column, you have a compression algorithm, but you might actually have multiple compression algorithms for different row groups within a column. If it noticed that patterns are the same amongst certain rows and not amongst other rows, you can have multiple different compression algorithms for different row groups of the same column. And a row group represents a bunch of the vectors. So they really optimize performance and storage, but simplification is what I think has caused DuckDB to be so widely popularized. And although they started off with working with the R community, which Hannes emphasizes is a really great, wonderful community, it's gained a lot more popularity actually in the Python community. So showing here pandas, a very typical usage of pandas here where you have a data frame in pandas. There's nothing DuckDB here, just a vanilla data frame. And you want to use this data frame. And instead of writing a bunch of pandas code, you can actually register this data frame with DuckDB and perform SQL queries on this data frame. Which is awesome if you prefer SQL over the pandas functions. And it also is awesome if you want to then join that data with other data sources, whether you want to join that data with a CSV or a Parquet file or a native DuckDB database, you can do that. And you can see at the end here, you can even get your results back as a data frame, which is also a really popular functionality here, is converting the results back to a data frame, because then you might have other code which operates on data frames. You can access your data in CSV files. The top loads and such are really just me adding in HTTPS support. And the reason for that is because they don't want to have any dependencies linked to DuckDB. They have a lot of these things are as extensions because they want to keep the core as lightweight as possible. So TLS support is an extension. But once I load that, I can easily load in from an HTTP URL here my CSV file. And not only is it a CSV file, but it is a gzipped compressed CSV file. And I can easily query that as if it is a table. And it will automatically interpret the columns and things like that. And then I can even copy that CSV file into Parquet format. So even if you don't use DuckDB on a daily basis, this type of functionality is super, super useful. And a lot of people use these sort of one-line snippets of code to convert data back and forth using DuckDB. And the next one I'm going to show you is with S3, which you'd expect. Again, needing TLS support. But the nice thing with the S3 support is you can actually access private data as well. So your data lake is in S3. You can access that, and you can actually read the data as Parquet files here. You'll notice I'm referencing a specific file. You can also reference glob patterns. So you can reference a whole directory worth of data and read, basically query your lakehouse from DuckDB. And then the last thing you can see here is oftentimes, yeah, we can access data in so many different ways, but oftentimes you want to bring that into DuckDB's format, and you can really easily do that with just create table as select from. It supports Postgres and SQLite databases, so if you use Postgres or SQLite as your transactional databases, you can actually take the data in from those databases and pull it into DuckDB, or in this case, pull it in and create Parquet files out of your transactional database data. So lots of flexibility here around how to access your data from within DuckDB. And that flexibility is really what a lot of people like about DuckDB. And there's more and more every day. The other thing is flexibility from where you're using it from. So in process, sure, you might not be writing Python code every day where you want to include the DuckDB library, but there's also a command line client for DuckDB. There's JDBC and ODBC drivers for DuckDB. And there's even in-browser support, which is done through WASM or WebAssembly, which allows you to run DuckDB entirely in the web browser. And you'll notice later, I'm going to show you screenshots of MotherDuck, and MotherDuck actually runs DuckDB on the client side in the web browser. Now, we'll say that DuckDB is for quote-unquote normal size data. What the hell does that mean? Well, I would argue that David here is correct, that the vast majority of the world's organizations do not have greater than billion-row data sets. Sure, we're in Silicon Valley, the heart of the technology industry in the world. Yes, there are many organizations around here which have larger than billion-row data sets, but if you think about all the organizations in the world, that's just not the case. However, DuckDB does work with larger than normal size data. A billion rows is not much for DuckDB. I wouldn't try to use DuckDB for petabytes or things like that, but I don't want to disqualify it from working well at any other data sizes. This is a quote from Mim, who opines a lot on Twitter, good guy, and he says, the irony of life, I never have done a query on a billion-row table, but when I did, it was on my laptop using an in-process database. And this is sort of a real-world industry data analyst, data engineer. And so you can use DuckDB for billion-row data sets, and I'm actually going to give you some demonstrations here on the taxi data. And this is from 2010 to present, about 1.5 billion rows. So showing some examples here. The first one here is I'm going to load from Parquet, and you'll notice that I actually said, I actually have a pattern here, a little, almost like a regex here, glob pattern of saying the 2010 decade and the 2020 decade, loading in the Parquet files and selecting the average distance from those. So this is about 1.5 billion rows, and it took about 3 seconds, the time that it took to appear on your screen here, in order to query over all of those Parquet files locally. But if I pull those Parquet files actually into a database in the DuckDB format, we actually can get it down to about 1.5 seconds. So super fast to query your data over these, even 1.5 billion row data set. Then I said, okay, how fast can we make this? Now this is 1.5 billion rows. It's not actually that memory intensive. It's really relying on the cores of the machine here, but I got it down to 0.145 seconds querying that data. So DuckDB can be used for pretty hefty amounts of data. I would argue that compute has changed so much over the last decade that we can scale up and don't need to do distributed querying for a lot of the work that we do. And the community seems to believe in this as well. If you look at the history of GitHub Stars for DuckDB, it looks something like this. And for those of you cynics in the room that have seen other people game their stars on GitHub, I will also show you this chart, which is the DB Engines ranking. So the DB Engines ranking looks across not only things like GitHub, but looks across Google search results, looks at job listings, looks at Stack Overflow posts, and a wide variety of other things, and is also seeing tremendous growth with DuckDB. There's a DuckDB Discord at the bottom left. I would encourage you all to join it. There's over 200 contributors to DuckDB. And then there's this weekly newsletter, which we publish with a community member named Marcos. Monthly newsletter. And Marcos actually finds it very difficult to limit the amount of content in the newsletter. So you'll see times where we publish top 10 links, and there's like 20 links, because there is so much happening in the community. From an innovation perspective, they do major releases every 3 months. And I'm going to give you some examples of those releases. So this is 3 months worth of work in the DuckDB ecosystem. I'm not going to read all of these, but you can scan it quickly and realize that they're accomplishing a hell of a lot in 3 months. So this is the next 3-month batch in 0.7. JSON support, partitioned export of CSV and Parquet. You can see a mixture between improving performance and doing things like improving the APIs and developer experience. 0.8, another 3 months later, added a Swift API so your mobile apps can use DuckDB, and added parallelized JSON writing, pivot and unpivot support. A lot of things happening really quickly in the DuckDB community. So it was created by these folks, and you might wonder, though, where did the name come from? And this is Wilbur. Wilbur was Hannes's pet duck. Hannes lives on a sailboat outside of Amsterdam and wanted to get a pet and couldn't figure out what pet he would get, so he decided to get a pet duck. And so Wilbur here is where DuckDB was named after. And although it can be kind of funny name to have, I'd rather have the name DuckDB than, say, CockroachDB. I don't know, it's a lot easier to do visuals when you think of ducks. So now you might be wondering, though, who the duck is mother duck? Who are we? So I come from this venture-backed startup. We are a bunch of data geeks from Google BigQuery, Databricks, Snowflake, Meta, Elastic, SingleStore. I actually used to lead developer relations for Databricks, and I planned this conference for the last couple of years, but I only got to plan it in the virtual world, never got to plan it in the physical world, so it's really nice to see the physical world coming together. But we're just trying to make analytics ducking awesome. We have a cloud version of DuckDB. We're trying to teach your DuckDB to fly in the clouds. That is the mother duck with the ducklings behind her. Now you might feel a little bit of whiplash here, though, and Mark felt it as well. Wasn't the purpose of DuckDB to run fast analytical queries in local? What is the need for a cloud version? Why are we doing a cloud version? Well, we do believe that your laptop is 85% idle. We do believe that you can get a lot of compute out of that machine. We also believe in the cloud, and there's a lot of functionality that the cloud enables, things like sharing and collaboration, that is not enabled by your local laptop. And so we say, what if you could do hybrid queries that execute across both your laptop and the cloud? And that's really what we aim to do. We aim to say, if we can take query plans that decide whether to bring the compute to the data or the data to the compute, then we can create much more optimized query plans. And that's exactly what we do. This is a high-level architecture of DuckDB and MotherDuck. And what you see here is MotherDuck actually is running on the right-hand side. It's a cloud service. And MotherDuck runs DuckDB inside of it, along with a MotherDuck server extension, using the standard extension libraries that DuckDB offers. But on the client, we actually have DuckDB running as well. So the client can do a lot of the pre-processing of SQL and send only the relevant chunks of SQL over to the server for processing. And the client can actually run in all sorts of different environments, including in the web browser. Now, what does it mean to have hybrid queries that are executing across these different environments? here is a SQL query that I've highlighted kind of the default of what you might look for. We have a table in MotherDuck here of New York City taxi trips, and we're looking at by passenger count, what is the average amount that someone spends on a fare for a New York City taxi. But let's say that we want to take that, and we also want to see what is the cost of that in a different currency. So we don't think in dollars, maybe some of you think in euros. We want to see that, and we have a file locally that represents the currency. Now, we could take that file and upload it to the cloud and deal with that process, make sure to get our permissions right and all of that, and then run a query. But with DuckDB, we could actually join against that local CSV file with this cloud resource. And all of a sudden, we have our average cost of our taxi fares based off of euros instead of dollars. And so, this query is actually being processed in part locally, in part remotely. I'm going to show you the query plan here in a second, which you can get via typing explain in front of your query. And I'm not going to go through every step of this. But what I am going to show you is that there's these little symbols in each part of the query plan here. This says R means remote. This part of the query operated remotely. And then there's cases where you see L's, and that part of the query operated locally. So we can really optimize where we're performing our queries. And a lot of people love to use DuckDB, for instance, to access cloud resources, things on S3, but their bandwidth isn't so high between their laptop and S3. Our bandwidth running inside of an AWS data center is a lot faster between S3 and our machine. And so this will automatically realize that in sort of a cost-based query analysis and access that S3 data through our servers and run the analysis there. And then you get your results, but the results are kind of the boring part of all of this. Your business leaders might not agree, but to me, that's kind of the boring part of all of this. So moving on. We do have, I alluded to this earlier, a notebook-like web interface. And the notebook-like web interface looks something like this. It has a built-in capability for doing pivot tables and all in the browser. Every result set that you get back can actually be operated on with SQL because we're running DuckDB in the client as well. So the result sets exist in DuckDB. So things like sorting and filtering the result sets are super, super fast. Things like generating these histograms, super fast. And you can see also we have our data catalog and all in there. Basic query functionality, but with this ability to do these hybrid executions. There is the ability to share snapshots of your data with others. And then we also like to say, if it can duck, it can mother duck. And by what I mean by that is that DuckDB will actually recognize that you have a MotherDuck database if you say MD : and then your MotherDuck database. So all you really need to change in many cases to go from working with DuckDB to working with MotherDuck is the name of the database that you're referencing. We've also worked with a huge variety of different partners to launch this. And here's an example. We would normally type DuckDB my.db. Instead, we just type MD myDB. And then it will do OAuth to get you authorization, and then we can run our queries here that will run hybrid. So DuckDB turns your laptop into a personal analytics engine. MotherDuck scales your laptop into the cloud by providing this hybrid execution support. DuckDB is great as you're developing, but when you want to move into production, having a cloud resource to move in production is often great for that purpose. And DuckDB is embedded. MotherDuck is more collaborative, serverless platform in the cloud. So you can visit motherduck.com and request an invite. We just publicly posted our documentation and other things last week. And we're starting to really roll out the number of invites that we're offering. There is also DuckCon. So this is run by the DuckDB Foundation and the DuckDB Labs folks, but there's a DuckCon event this Thursday. It's from 4 p.m. to 6 p.m., and there are still a few tickets available. Mother Duck is also hosting a party after that, and it'll be a lot of fun and include things like skee ball for those of you who grew up with that. It's a lot of fun. So register for DuckCon if you're interested in learning more. There's 2 hours worth, including a bunch of external speakers as well as from the original creators of DuckDB. And hopefully you can also make it out to the party.